Edison, Bell, Marconi. These inventors evoked the beginnings of electrical engineering, electric power, the telephone, and radio. With advances in telecommunications and electronics came computer engineering and computer science. Today, electrical and computer engineering permeate every facet of our lives. As a professional in the field, you can pursue interests as diverse as medicine, aerospace, telecommunications, software, hardware, the environment, law, and more. One thing is for sure, no matter where you work or what kind of work you do, there are certain constants that make for success. Technical competence is obviously a very important one, but there is more that you can do to prepare for a career, and that's what this video is about. Let's start with the basics. How important are they in your undergraduate studies? Should you focus on some particular area of interest to the exclusion of a broader engineering education?
Just get the basics. That is the most important thing. You get the basics. When you come out into the workforce, you'll learn everything, because once you come out, you don't know everything. You're still learning every day. So get the basics, and you can use the basics to go and do just about anything that's basically put in front of you.
What we find are students frequently that dispense with the fundamentals and quickly elevate themselves to working with fancy tools, fancy algorithms, fancy mathematical expressions and formulas, and don't really have a good firm grasp of the fundamentals, because the tools are going to change and evolve, and people are going to move on to other things. If you have a grasp of the fundamentals, then those things don't change. You'll be able to move to a new field, apply your skills and your basic understanding of physics and chemistry and mathematics, computer science, in a much broader set of applications.
The people who are retained are the people with the broadest base, the people who can do a lot of different things for you. My boss appreciates the fact that I can do not only AC power, but I can also do pulse power electronics, I can also do fiber optics. This is important to the management nowadays, that you be very flexible and versatile. If I were to do it over again, I would ensure that I was as flexible and versatile as possible.
A lot of engineering students consider non-technical elective requirements an unnecessary distraction from their goal of becoming an engineer. But that's not what engineers in the field tell us.
I would probably recommend that everybody have a basic understanding of finance and accounting, because, like I said, the world is business, and we're becoming a global country. I mean, every local business is becoming regional, regional is becoming national, national is becoming global. And you have to understand how your company makes money. And you wouldn't be working for that company if they weren't in business. So you need to understand either what cost you're containing or what revenue you're helping to contribute to, and it's just imperative you understand that.
I suggest ethics because one of the things that causes some engineers difficulty is that they look at engineering as a black and white world. If the formula fits, you do the calculation, you get the numerical answer, you're done. But that's not the way it works in reality. In reality, we have to go beyond the technical and legal requirements of a problem and look at the ethical considerations. And that's a very gray area. And that calls for knowing oneself very well and what makes you think the way you do, what makes you believe the way you do, and helps you to make judgments which are different than just coming up with answers.
Well, one of the best courses I took as an undergrad was actually a technical writing course. And as part of this course, we had to actually sit down and write a user's guide or a user's manual. We also had to give presentations and critique others' presentations, and then also do some additional writing. And I found that coming right out of school, it was no more than 6 or 7 months being right out of school, I was beginning to give presentations to my team and my managers and stuff like that. So it really put me at ease to have those sort of skills and that fundamental under my belt. I
notice in meetings, we have several meetings. On average, I attend 2 meetings per day, every day of the week. And as important as it is to be technically competent, it's very important to be able to communicate those ideas. I see in myself and other people that those that can communicate to the highest level are the most successful?
Well, interestingly, I would look for language. We're a global organization. Many of our jobs are not in the U.S. In fact, I think it's 40% of our technology jobs are here, 60% are overseas. And so I'd like to see somebody who actually speaks another language.
Sometime during your first year in college, you'll probably hear about internships and co-ops. These are engineering jobs that allow you to learn in the workplace outside the classroom and perhaps earn a little money as well. Even though they might delay your graduation, should you take advantage of the experience?
The one piece of advice I could give is if they could do co-op at all, job-related, to definitely do that and get as much experience as they could along the way. One, it helps them when they're ready to graduate and look for a job. Employers see that experience in their background. It's a lot easier to get a job. And it also will help clear the way that first year. Your learning curve the first year is pretty steep, and any experience you can gain prior to graduating college will definitely be a benefit.
I spent 6 months in school and 6 months on the job, and what you learn from that is there's on-job experiences that you just don't learn in school, and that really helped me later on when I got out of school.
What I learned from my internships was that engineering job was as much about communicating with other people and understanding and trying to get concepts across to other people as it was about designing and doing the actual detailed work.
Both in my undergraduate school and my graduate school, I took time off and worked. When I was in undergraduate school, I went and worked at Jet Propulsion Laboratory. And that really opened a lot of doors for me. In fact, that's why I ended up getting a job at Los Alamos, because they had seen a presentation I gave there, and somebody remembered me, and eventually I got hired here.
Just like all the other practical lessons that you can learn, I think that co-ops are really valuable. But the one caveat I want to apply to that is that you need to pick an internship, a co-op opportunity that meshes well with your interests. Because like engineering jobs, there are really bad co-op jobs out there. But also like engineering jobs, there are really good co-op jobs out there. And you just need to find the one that matches well with your interests.
At some point in your college education, you'll probably consider going for a graduate degree. It's generally acknowledged that the higher the level of education, the higher the salary. Should you go for it?
A bachelor's puts you too much in the sea of technical people. I recommend everybody get a master's degree in order to strengthen the final stages of their technical development, put themselves a little ahead of the masses with bachelor's and double E. And it gives you a sense of being poised, not having to be afraid that you don't know enough. You can ask anybody a question, even a PhD.
If you really want to go to graduate school, you do it because you want to go. And if you just convince yourself, well, I'm going to get my PhD so I can make lots of money, that's just a terrible reason. And you're probably not going to get through because it's a lot of work. It's really a lot of work. And you have to be really committed to it personally. But if you are committed to it personally, you don't have to have any other reason. You don't have to explain to someone why you're doing it if it's something that you truly want to do.
I'd say the MBA, I wouldn't be here without the business degree, but I don't think I could do my job as effectively or understand some of the engineering and technological trends that are going on without the engineering background.
Professional associations can provide a network of contacts to help you find a job and move your career forward. They also offer a variety of services like job referral, continuing education, insurance, travel benefits, periodicals, and meeting and conference opportunities. Joining will probably do more for you than just add ink to your resume.
Throughout college, I belonged to different ones. IEEE, Society of Hispanic Professional Engineers, various societies throughout colleges that are being offered. Interesting enough, if you take the time and you actually attend the meetings and listen to people, you can begin to understand what each of these groups do. And you also have the opportunity to attend conferences, which I did. And it helped me focus because by attending workshops, listening to people, understanding what's going on in the industry, I could understand where I could fit in.
The IEEE is certainly probably the most useful of the organizations in terms of having a large set of publications so you can pick a few fields that you're interested in, get their transactions, and keep up on that.
There you're going to link up with other professionals that are doing the similar things that you're doing. And in your job, you never know what problem's going to come up that in your day-to-day conversation or going to the conference, you're going to find out these issues and you're going to know, hey, I met somebody at the IEEE conference, or I got to this organization and I have a contact there that I can do some information sharing and lesson learned type of thing. We want our people to be able to build that network.
But then there's another side of this, and that is through the professional society, you also get a chance to basically also serve your industry, because a lot of the professional society will do standards or will work on tutorials, or you work on the supplying side of this professional society benefit. And so it's time for you to pay back then to an industry that maybe you've been the receiver of the benefits of that technical society in the past.
More states are now requiring the professional engineering license in areas that affect public health and safety, such as air traffic control, aerospace, medicine, and even amusement park rides. You can begin the licensing process in your senior year by taking the Fundamentals of Engineering test. It might be a good idea to take the test before graduating, just to keep your options open.
Initially, there weren't too many people who had their PE licenses here. The numbers have grown, and I recommend it for anybody coming into this field because legislation is gaining strength. For many years in past history, there's very little legislation of ride systems, amusement systems. But what we've seen is a growing body of legislation, starting in Florida because of the sheer quantity of theme parks. And we expect to see that spread to other states. And it doesn't hurt to be a licensed engineer, because I expect that we'll get to a point where, due to liability and the litigious nature of our society, that ride systems will need to be approved by professional engineers, not just facilities electrical.
Now that you're on your way to getting it right during your college years, let's take a look at some real-world issues that you may encounter when you finally get that job. In engineering, learning doesn't stop with college. Whatever you call it, continuing education, lifelong learning, or professional development, the success of your career will depend on keeping current.
We look for students who are determined, who are interested, who have curiosity, and who are committed to lifelong learning. Because the technology and industry and business are moving so rapidly now that an education over a 4-year or 5-year period or 6-year period is no longer enough. You need to be self-educating all the time.
I've never stopped learning. I've been out of school since 12 years now. And I carry a good collection of technical reference manuals back and forth from home to work so that I can always stay up on the latest and greatest either software or something in electronics, because you're always challenged here at Disney.
The engineers need to be aware of what's coming, what's going on in allied fields, what other companies are doing. So getting out and rubbing shoulders with technologists from other companies, learning the latest in technology, those are really important for an engineer to keep his career moving upward. Otherwise, the engineer becomes a technician after a number of years.
I have had to retrain myself several times. The way I do this is with the trade press, with self-education, participation in the IEEE as someone who I'm now the chairman of the Seattle section of the Communication Society. So I set up these talks. I give some of them. I listen to the ones that I set up that I don't give, because I'm trying to learn stuff that I don't already know, because I'm going to need it a year or two from now. I just don't know what I'm going to need. That's what I have to do to stay employed in this culture.
A mentor is defined as a wise and trusted teacher and can be a big help in your career. Some companies have formal programs, but most mentoring happens on an informal basis.
It's very important that you get good mentoring. And that doesn't mean your specific boss has to seem like a great mentor, but the place you go has to have enough time for some very skilled people very wise people to take some time with you and work with you to answer questions, to help you figure out how to solve problems that seem difficult, formidable. You need access to mentors.
As a young engineer, when I first got out of college, my first job, I was in a field where I didn't know anything about the field. It was with neural networks. I'd never been exposed to neural networks, never used them or anything. And there was an engineer on my project, and he kind of took me under his wing, and he made sure that I got all my questions answered. He made sure that my questions, were not trivialized, were not minimized, and he really helped me figure out how to get things done and how to ask questions.
The role of the mentors is an official role at Texas Instruments, and it's helping the people understand how do they go from the role they currently have to the role they think they want. What training might they need? What job responsibilities? What skills do they currently not have that they would need to get?
Today, a diverse work environment is considered to be a strength by almost all corporations and institutions. It takes all types of people with unique problem-solving skills to engineer a successful product.
I was surprised, pleasantly surprised, when I joined on at IBM. There's a big diversity here, a lot of different minorities, men, women, young, old. I mean, you cover the entire gambit here, and I was happy to see that when I got here. It made my transition from college to employment a lot easier.
When you come into a new department, there's, at least from my opinion, that there is a time where you have to excel and produce more spectacular results at a faster rate than your male counterparts. But once you do that, you're on an equal par. So it's only an initial thing.
And frankly, it serves the company best to hire from all ranks of life, ethnicity, training, background, beliefs. It also keeps the place alive and fresh with new ideas and new philosophies. People come from different backgrounds. I think it strengthens the company.
In today's workplace, disability is no longer a barrier to an active and fulfilling engineering career.
We've got the parking spaces and the Americans with Disabilities Act, and you've got the curb cuts, and you've got a law. And the law says that the business, if you have the necessary skills, the business will make what they call reasonable accommodations. In this case, reasonable usually refers to cost. You don't want to put a business out of business to help someone, but what is reasonable? So I have a reasonable accommodation that I've asked from Tanner. I don't fly. Flying is still a very difficult task for handicapped people. It takes a lot of time. You have to get on the plane first and get off the plane last. They lose your wheelchair. There are all kinds of pitfalls associated with flying. So I just request not to fly and discuss that with my management, in an open way about the problems associated with it, because they don't know. I have to go through some of the details so they can internalize the difficulties. And then they usually agree. I've only had to go on one trip in 19 years.
When you start your first job, you're going to experience a lot of situations that are different from college. The skills and attitudes formed in college do not always include the ones you'll need to succeed at work.
In industry, we expect you to work on teams and get answers from other people. That's not called cheating. But in college, if you're in the middle of the final and stuck on a problem and leaned over to your person next to you and said, I don't get number 3, can you tell me the answer? The professor would throw you out. In industry, what we do is reward you and say, great job, you found it sooner. So there's a whole new set of operating rules when they leave the university and go into industry, and the students should expect to see a change in that rules. A lot of students, engineering students, have a difficult time the first 2 years because they think industry is just like the university, and it isn't.
Yeah, I thought, that engineer, you go out and you go play in your lab with your equipment, your toys or whatever, and I find that there's a lot more bureaucratic stuff going on, a lot more meetings, paperwork and forms to fill out, regulations and stuff that you have to comply with that I didn't know about while I was in school.
What they don't teach you in school is the politics. And this is something that you don't recognize when you first hit the work world. It depends on how much politics you run into prior to that, but that's that was the greatest shock for me, was the politics I ran into when I got into the work world, and how a lot of really great scientific ideas were thrown by the wayside because the person that was proposing them was not politically astute.
I went to U.S. Robotics last Friday and talked to top management. I listened to them, and then I told them what I needed from them, and then I listened to their response. Those skills they don't teach you in engineering school. Those skills they usually don't teach you in school at all. Those are the most critical, because business is a team sport. It's not a bunch of prima donnas, each of them achieving individual. The myth of the programmer in his garage or her garage writing the killer application is, in some ways, a myth. They surf on the efforts of a whole lot of other people. And then somebody else is going to take the tech support call.
Stay in engineering or move into marketing, sales, or management. Sometime into your career, you'll likely face these decisions. The direction you take will depend on your interests and skills. A move away from technology may be right for you. Then again,
I enjoyed the technology area of my earlier jobs, and very often when you're a technologist and you're pretty good at communicating, they'll say, well, how'd you like to be a manager? So they said, Paul, we'd like you to manage this group. Fine, that was a lot of fun. I became a director of a group called Product Integrity, which worked with customers, did configuration management, a lot of the support areas for product development. And as the next step was to become a vice president, which I did. And that was good for a couple of years, but that's not really my forte. I enjoy managing to a certain extent, but I really enjoy the technology. So I made a transition back into, became an advisory design engineer, and I've been an engineer, actually a technical person now, for about the last 15 years. I enjoy it much more.
Originally, I thought I would take a leap over into a managerial ladder. Although now, after 2.5 years of working, I find I really enjoy the technical. And as long as I can contribute and stay up with the technology, I'll probably stay technical.
How I got into marketing is a complicated story. I started off in the distribution side of the company, working on getting electricity to our customers' homes. Then I moved into the transmission engineering department, working on the issue of electric and magnetic fields for our transmission facilities, and decided that I had spent a long time in engineering and wanted to try something different. Given the communication and interpersonal skills that I had, I thought I might be well suited for marketing and sales. So I got myself a position in the wholesale marketing group.
Is all the work that goes into preparing for an engineering career worth it? What motivates these engineers? What gets them to work in the morning?
Finding new ways to solve problems every day and make it better and beat that competitor. That to me that's the thrill of the chase. That's what brings me into work every day.
I never know what I'm going to be doing that day when I show up. Yes, I have a calendar, and my calendar is usually full. And by the time the day is over, I usually look at my calendar, and I didn't get to do any of that stuff because other more interesting things have popped up.
My job allows me to basically come in and I play around with next generation technology, future technology. We're developing technology here that people won't see for another 2-3 years.
You know, I've always enjoyed going to theme parks. I always enjoyed going on the rides. I always enjoyed seeing the shows. And now that I can be a part of doing that and still doing engineering, it blends the two things I like most.
I worked on the 777, the 777 airplane for 3 years, and the day they ran the engines for the first time, and I got to be on the flight deck to watch to see if my generators came online. And they did. I mean, that was neat. That was probably the most exciting thing. The second one was the day it flew, and we all walked out and watched it take off. And when we heard it was going to go land, we all ran out and watched it land again. Yeah, that's fun to see.